This video is for the quiz retake. This is the functions quiz. My recommendation is to watch me do a question, then you answer the question, and then watch me do number 2, and then you do number 2. To begin, number 1, it asks whether or not the relation is a function or not. For it to be a function, x's cannot repeat. Okay? So that's one of the things you need to watch for. The x's can't really repeat. The other thing is there can only be one answer, if I can spell it right, for every x. Okay? Only one answer for every x. So let's look at relation 1. In relation 1, we have a -1, -3, 2, -7. They all just list once. Remember, this is x, comma, y. So we're looking at all our x's. There's an x, there's an x, there's an x, and there's an x. None of them come up twice, so that tells us it is a function. Okay? And if we look over here at the second relation, we have x, 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 x. Now we know they're all letters. That doesn't matter. X can be anything. And so as long as they don't repeat, okay, they can't repeat. So we have n, f, m, r. And nothing there repeats, so that tells me it is a function. Okay, next. Our domain is the same thing as our x, and our range is the same thing as our y. So we see there's only one answer for this x, one answer for this x, one answer for this x, and one answer for this x, telling us it is a function. As long as there's only one answer for each x. Okay, now relation 4, again we have x and we have y. And we look at each one. There's one answer here. But here, what do we see? We see two answers. One going here and one going down here. If ever there's two answers, it can't be a function. Remember, there can only be one answer for every single x. So this one is not a function. Number 2. Okay, now here we're asked for the domain and the range. Domain equal all our x values. Okay, domain are all our x values. Range are all our y values. So we want x's here and we want y's here. Now remember, this is x, comma, y. So what are our numbers? We have 1, comma, 2 x's and y's. We have 1, comma, -7. Now right away you can see it's not a function, right? Because 1 repeats, but that doesn't matter. It's not asking for the function, it's asking for the domain and the range. And then we have 3, comma, 7. All I did was relist all of these on top of each other right there. The reason why I did that is because now I can see what all my x's are. They're 1, 1, and 3. Now you don't have to relist the domain twice if it's there, so I'm just going to put 1 and a 3. Always put it inside brackets, 1, comma, 3, just like that. Now if I continue on to the next one, I look at the y's. What are all our possible y values? All our possible y values are 2, -7, and 7. So here, inside brackets, I'm going to put 2, -7, and 7. Just like that. And that's how you do number 2. Number 3. In number 3, we're looking for a vertical line test. We're trying to decide if it is or is not a function. Okay? So if we look at the first one, we see kind of a sideways V, part of a triangle, and we want to know, is this a function? Well, to find out if it's a function, we do a vertical line. And if you look, anywhere I draw that vertical line, you see I'm coming up with 2 answers. Okay? Vertical line test means it can only have one answer, but we see right here, crosses once, twice, once, twice, and so on. If it crosses that vertical line twice, it is not a function. Okay? In other words, if I look at the answers for where x is 4, I get 2 answers, right? And I can't have 2 answers. I can only have one answer. So let's do the same thing here. When x is 3, how many answers do I have? I only have 1. When x is 1, how many answers do I have? I have 1 here and 1 here. I can't have 2 answers. So that is not a function. Okay, next one. Right here, you might think, hey, right here there's 2 answers. But that's not the case. The open circle means it is not one of the answers. Okay, so right here, this is not an answer, that is. Not an answer, that is. So anywhere I draw a vertical line, or any x, there's only ever one answer. So that is a function. Okay, if we continue on to the next one, we say, okay, vertical line test. If we draw any vertical line anywhere on this, we see that it only ever crosses the line once. Okay? There's only one answer for every single x. So that is a function. Here, when we have -5, one answer. -3, one answer. 0, one answer. 2, one answer. And 4, one answer. So that is a function. Every x only has one answer. Now if we look here, vertical line test, we're going to get 2 answers, especially when x is 0, we got an answer down here and an answer up there. We can't have 2 answers. So that's how you do number 3. Number 4, we're looking to see if it's a function or not. And here we have B, G, B, G. We have these 2 and these 2. X's can never repeat themselves. So now that those x's repeat themselves, it is not a function. You can say, well, when I plug in a b to the function, what do I get? Well, I get either a -3 or a -7. Now we look at the next one. X comma y, right? And we have -2, 4, -9, 9. Nothing repeats itself, which makes it a function. Here we have x and y, so we have one answer for -1, one answer for -5, one answer for 2, which tells us it is a function. We never look at the y, only look at the x. Okay, and here we have one answer for the f, again, x and y, one answer for the z, one answer for d, one answer for w, but look right here. There's 2 answers for this one going to R and one going to C. We can't have 2 answers, so that is not a function. Number 5, vertical line test again. Anywhere I draw a vertical line here, I see it only touches each answer once, so it is a function. Here, when I plug in this x, I only get one answer. This x, one answer. One answer, one answer. When I plug in 0, I get one answer, and when I plug in 5, I get one answer. So that is a function, as long as there's only ever one answer. Here, I have a vertical line test, and like right here for 2, if I get 2 answers, right? And 4 and 6, all of these have 2 answers, so it is not a function. Vertical line test here. Let's use the y-axis as our vertical line. Look, it has 1, 2 answers. We can never have it overlap like this, so it is not a function. When I go -5, I have one answer. -4, one answer. 1, one answer. 3, one answer. But 4, I have 2 answers. I can never have 2 answers. And a vertical line check here. Even if I use the y-axis as our vertical line, look, I have one answer there and one answer down here. I can never have 2 answers. It has to pass the vertical line test. Okay, number 6. Number 6, what's going on here is we're getting the x's, and we're asked to plug them in right there. Now remember, this is not a math problem. It is just a title. So we're only plugging the x in right there. So I have 2 times -4 plus 1. What's 2 times -4? It'd be -8. -8 plus 1 is -7. Now if I plug in a -1, 2 times -1, I'll write it out. 2 times -1 plus 1. Well, 2 times -1 is -2 plus 1. -2 plus 1 is -1. If I do a 2 times, a 1, plugging in the x right there. So 2 times 1 plus 1, that's 2 plus 1 is 3. If I do a 3, 2 times 3 is 6. 6 plus 1 is 7. If I do a 5, 2 times 5 is 10. 10 plus 1 is 11. And that's how you do a question like number 6. Number 7, same thing, but now we have 2 functions. We have an f function, and we have a g function. So we just have to plug in what we have here. We're asked to put a 5 in for x. Well, there's x. Again, this has nothing to do with it, and this has nothing to do with it other than the title. Okay? So we see our f, we want to replace x with 5. Our f, we're replacing x with 5. So we have -4 times 5, always use parentheses, minus 1. -4 times 5 is -20, minus 1. -20 minus 1 is -21. So -21. If we do the same thing for the g function, we see, hey, instead of x, we're putting a -3. So we're going to take that -3 and put it right there for x. So -3, parentheses, and what are we putting in for x? -3, right? Cubed minus 2. Well, we have to do the cubed part first. -3 times -3 is 9. 9 times -3 is -27. So we've got -3 times -27 minus 2. And -3 times -27, I'm just going to do that on the calculator just to make sure I'm doing it right, is positive, 81 minus 2, and that's 79. So 79. Number 8. Again, this time we're back to only one function. So we have x, and we're going to the h function and replacing the x, okay, with what? -2. So let's put that in there. There it is. X is up there. So 4 to the -2. Whenever there's a negative in the exponent, it means we flip the fraction. So this is the same thing as 4 over 1. So we're going to flip the fraction, 1 over 4 squared. Now notice the negative is gone, okay? So what's 4 squared? It's 16. So 1 over 16. And that's our answer. 1 over 16. Remember, it's not times, it's an exponent. If we do the same thing with -1, we have 4 to the -1 power. We flip that upside down, it becomes 1 over 4 to the 1 power. Anything to the 1 power is itself, so that's 1 over 4, not minus. Okay, anything to the 0 power is just 1. So that one's easy. Now what's 4 to the 1 power? Just 4. Anything to the 1 power, it stays itself. And 4 times 4, or 4 squared, is 16. Now in this problem, you might recognize this as an exponential function. We have y equals, and this is the y-intercept. Let's change that color. Times, this is the change, rate of change, you know, kind of like the slope, raised to the x power. Okay? So, excuse me. So, from there, we can say, hey, our y-intercept is always our beginning point, our initial value, our starting point. Okay? This is our starting point. And this is how fast it's changing. So where am I starting? At 24,500. So that's my initial value, 24,500. And what is it after 11 years? Well, to do that, we take 24,500 and we're replacing t, or time, number of years, right there. So 24,500 parentheses 0.78 raised to the 11th power. And that one we need to do on a calculator. I can't do that one by hand. So I'm going to click the calculator up here. And what do I have? I have 24500 parentheses 0.78 raised to the 11th power. Then just click down here, parentheses, enter. And I get that amount of money right there. So how much is that? Well, I want to round my answer to the nearest dollar. Okay, round my answer to the nearest dollar. So I've got 1593. Oh, 1593, not 73. 1593. And that's my answer. Okay. Now our range are all our y values. Domain are all our x values. Okay. So we want to know, when we plug in this for x, what do we get? So we've got 2 minus 3 times x, which is -1. Well, -3 times -1 is +3. So 2 plus 3 is 5. So our first range is 5. And with that, I'm going to put a point over here too. When I plugged in -1, I got 5. So I'll put a dot right there. Now we're going to do the same thing, but this time we're going to do the 0. So here's my next x. Plug that in for x. 2 minus 3 times 0. Well, 3 times 0 is 0, so that's just 2. So I'm going to put my next point. When I plugged in a 0, I got 2. So when I plug in a 0, I get 2. Now we're going to do the 1. 2 minus 3 times 1. -3 times 1 is -3, so 2 minus 3, that would be -1. So that's what goes here. -1. And over here, when I go to 1, I got -1 right there. And the last one, I'm going to take the 2 and put it there. 2 minus 3 parentheses, and I'm putting a 2 there. -3 times 2 is -6, so 2 minus 6 is -4. -4. And again over here, when I plugged in a 2, I got -4. And there we have it. With that domain, that's our range. Now what's the problem here? The problem here is it's got to be in order from smallest to biggest. So I'm going to have to rewrite that. -4, -1, 2, 5. So let's go ahead and do that. It always has to be smallest to biggest. -4, -1, 2, 5. All right, on this one, we're given an equation. Yeah, we've got a whole bunch of information here. The fuel tank of an airplane can hold 200 gallons of fuel. Let W, this is important, let W be the total weight of the airplane. Okay, so that's W. Now let F, I'll make that a different color. Now we're going to let F be the total amount of fuel in the tank. Okay, good. Those are important. Now what are we trying to find? This equation is in the format of y equals mx plus b. If you remember, plus b is our y-intercept, or in every story problem, it's our starting point. This is our slope. This is our domain. And this one is our range. Okay, now those are all the parts. Now we may not use all the parts, but those are all the parts. So let's go ahead and go through it. Domain. Well, domain are our x values. But in place of x, what did we have here? We have f, where x should be. So our domain is f, and our range, which is where y should be, is w. Well, what does f stand for? We go back up to our problem. F is the total amount of fuel. So there we go. What does W stand for? W is the weight of the airplane. Okay, there we go. Now fuel, how much fuel can they have? They can have 0 fuel, but the fuel tank can hold up to 200 gallons, no more, up to 200 gallons. And we can have 0 fuel, runs out of fuel, it crashes. So it's all numbers from 0 to 200. What about the weight of the airplane? Again, we're starting right there at 4,000. Okay? We're starting at 4,000. If we put 0 fuel, 5 times 0 is 0. 0 plus 4,000 is 4,000. So no matter what we have in there, it can't weigh less than 4,000. If we put 200 in there, that would be 1,000. 1,000 plus 4,000 is 5,000. So this is just saying, if I plug in that 0, what would I get? If I plug in that 200 right there, what would I get? Okay, and that's how you answer that one. Number 12, same question. Let's go through and see if we can find the same information. So right here, we're going to let W be the total amount of water. Okay, and then we're going to change and let T be the total number of minutes the water has been added. So there's our T and our W. Okay, now that is also the same thing as Y and X, which is range and domain. Okay, so X and Y, or in our case, we want T and W. Okay, because they replace the X with the T and the Y with the W. So what does T stand for? It is the total number of minutes the water has been added, right? T, the total number of minutes. And what does W stand for? W stands for the total amount of water in the pond. Just like that. Now, total number of minutes. Can we have 0 minutes? Sure. Is there a maximum number of minutes? 90 minutes right there. Okay? So we can have 0 to 90. Now, if you can't remember that, think about it this way. There's only 2 answers that have zeros. This one, you can do half a minute, 10 seconds. I mean, can I add water for 10 seconds? Yes. However, down here, it's saying only 1 minute, 2 minutes. You can't stop unless you fill the full minute. So, logically, we can eliminate stuff. Now, right here, if we plug in that 0, 25 times 0 is 0. 0 plus 400 is 400. So this has to start at 400, and there's only one that starts at 400. And if we were to plug in 90 there and do the math, we would get 2650. Or you can think of it this way. Where did we begin? We started at 400. We start at 400. Okay? And that's the Y-intercept. Remember? Y-intercept. Okay, domain and range. In this case, we don't have any lines or anything. We just have X's and Y's. So we're going to look at all the X's. That one goes to 2. That one goes to 1. That one goes to 2. And that one goes to 4. We're looking at all the X's, not the Y's. We don't care about the Y's. Okay? So our domain are all our X's. We have -2, always smallest to biggest, 1, 2, and 4. Okay? Now if we do the same thing with the Y's, we see this one goes to 2, this one goes to 1, this one goes to 0, and this one goes to 3. Again, now we don't care about any of these numbers right here. Those numbers are useless to us. Okay? It's as if those numbers don't even exist. We're not even looking at x. So the x numbers don't exist. So like that. So we see 2, 1, 0, negative 3. And that is what we put here, from smallest to biggest. So our smallest is negative 3, comma, 0, comma, 1, comma, 2. Number 14, same thing. Okay, to start, we're going to look at the domain, which is our x, and range, which is our y. So our domain is x, so we don't care about the y. We're not going to look at the y. The y's don't exist. So there we are. The y's are all gone. There is no y. So what do we go to? Well, we go to negative 4, that one too, negative 4. And we go to negative 1, and we go to 2. And so those are our answers. Lowest to highest, negative 4, comma, negative 1, comma, and 2. You don't list it twice. If it only shows up once, you only list it once. Okay, now we're doing the range. The range of the y, so the x doesn't exist. We don't look at the x. The x is gone. We're only looking at y. So I'm going to get rid of all the x's. Now if we look at all the y's, this one goes to 2. This one's right here between 1 and negative 1, which is 0, right? This one goes to negative 1, and this one goes to 4. So our numbers from smallest to biggest are negative 4, comma, negative 1, comma, 0, comma, 2. Just like that. And it doesn't matter if they're not the same number of numbers. That's perfectly fine. Okay, domain and range. Same thing. This one's range, so it's y. This one's domain, so it's x. So we're doing the range first, which means we don't care about the x. Which means all of these x numbers don't exist. Okay, they're all gone. So let's look at where we start. Where's our lowest range? Well, it goes all the way down to here. So what is the lowest number? Just follow it over. It goes all the way down to 0. Because those numbers don't exist right here, right? So all I have is this number line. And it goes all the way down to 0. And it goes all the way up to 225. So our range is 0 and 225. There's a line, so it's not a list, which means we have y in the middle, less than, less than. Now is this a filled in circle right here? Yes it is. So I'm going to put that right there. And is this a filled in circle right here? Yes it is. So I'm going to put that right there. So that's what I need to type in here. Okay, so I have the 0. Then I have less than or equal to. I have y, less than or equal to. And I have, oh, we don't want a capital Y. Less than or equal to 225. Just like that. Okay, now we do the same thing for the other direction. Now, because we don't have, or because we're looking at x's, the y's don't exist. Okay, so this one is just going to kind of, I'll try to scribble it out as best as I can here without taking too much time. Those numbers don't exist, so we don't look at them. We're only looking at x. Okay, only x. So where's our lowest x? Well, the only number that is available goes down there to 0. So we have 0, and the highest number is 45, with an x in the middle, less than, less than. And what do we have here? That's a filled in circle. So that goes a line there, and that's a filled in circle, so we get a line there, which tells us that we have 0 and less than x, less than or equal to 45. We just copy as we wrote it on our scratch paper. It's easiest to start on your scratch paper. Number 16. Graph the exponential function. Okay, so to graph a function, we always want to do a t-chart. Okay, here's our x values. Okay, we're told right there. So that's -2, -1, 0, 1, and 2. That's our x. And our y values are what we get when we plug it in. So let's put x for x. We have 4 times to the -2 power. Now what does the negative power do? We flip the fraction upside down and we get 1 over 4 squared. What's 1 over 4 squared? That's the same thing as 1 over 16. Okay, now we do the same thing with the 1, or -1, so 4 to the -1 power. That flips upside down because of the negative right there. So it becomes 1 over 4 to the 1 power, which is 1 over 4. Anything raised to the 0 power is 1. Let's do a 1. 4 to the 1 power is 4. Now let's do a 2. 4 squared is 16. Okay, so now we have all that we need. Let's plot those points. Use this button right here if it's a fraction. We have -2, comma, not 0.2, -2, comma, 1 over 16. And that's just 1 divided by 16, or you can use the fraction button. Plot point. Okay. -1, -1, comma, 1 over 4, plot point. Now the rest of these are whole numbers, so I can easily just do it this way. 0, 1 is right there. 1, 4 is right there. And 2, 16 is right there. Once you have all the points plotted, you just click this button to draw the line. And there's your function. Let's do that again. Okay, again, we have our t-chart with our x and our y. So when we plug in our x's, we have -2, -1, 0, 1, and 2. So -2 goes there. We have 4 over 5 to the -2 power. What does that negative tell us? This negative right here tells us that we have to flip the fraction upside down. Okay, so that becomes 5 over 4 squared. And that squared goes to both of these. So what's 5 squared? 5 squared is 25. What's 4 squared? 4 squared is 16. Okay, and we did it with the other ones. When I had like 1 over 4 squared, same thing. 1 squared is 1. That's why I didn't do much there, because I knew in my head that 1 squared was 1. Okay, now negative 1. Let's do that. We have 4 over 5 to the negative 1 power. Now that negative 1, again, means that we're flipping the fraction upside down, which gives us 5 over 4 to the 1 power, and anything to the 1 power is itself, so that gives us 5 over 4. Anything to the 0 power, if I plug in a 0 right there, anything to the 0 power is 1. Anything to the 1 power is itself, so 4 over 5. And now if we plug in a 2 for the x, we have 4 over 5 squared, and that squared goes to both numbers. So we have 16 on top and 25 on bottom. Good. So let's plot the points. We have negative 2, comma, 25 over 16. Plot that point. We're going to click that button again. Negative 1 over and 5 over 4. Plot that point. Okay, once again, we have, oh, I could have just drawn that with a pencil. 0, 1. And again, we have 1, comma, 4 over 5. And then the last one, we have 2 and 16 over 25. Okay, now I'm going to plot the graph, and if you see anything other than that gentle curve, you did it wrong. Okay, it can't be an S or a squiggly or anything. It has to be that gentle curve. Okay, we're doing the exact same thing here that we did on the other ones. So we're taking each one of those x's, putting them right there for x. Okay, each one of them. So let's go ahead and do that. We have 5 over 4 times 2 raised to the negative 2. Now that negative 2 only counts towards that 2 right there. Remember, you got to do the exponents first. So what does that negative tell us? That negative tells us that we have to, the negative tells us we have to flip this over. So that becomes 5/4 times 1 over 2 squared. Now it's a positive squared. Okay, it's flipped over. And again, that squared goes to both of them, but the top one just stays there. So we have 5 over 4 times, what's 1 squared is 1. What's 2 squared? 2 squared is 4. And when you multiply fractions, you just multiply straight across. Okay, so we're just multiplying straight across. 5 times 1 is 5. 4 times 4 is 16. Okay, so I'm just going to plot this point now so I don't have to worry about remembering it. When I plugged in a negative 2, I got 5 over 16. Plot point. Okay, so now it's there. I can erase my notes, go on to the next one. We have 5 over 4 times 2 raised to the negative 1 power. And again, that negative tells us that we flip the fraction upside down. So that becomes 5 over 4 times 1 over 2. And that's all to the 1 power. But to the 1 power means that everything just stays the same. So now let's go ahead and multiply straight across. 5 times 1 is 5. 4 times 2 is 8. So when I plugged in a negative 1, I got a 5 over 8. Okay, 5 over 4 times 2. Now we're on the 0. Raised to the 0 power. Anything raised to the 0 power is 1. 5 over 4 times 1 is 5 over 4. So that tells me when I plugged in a 0, I got 5 over 4. Plot the point. Now we're on to 1. So we're going to plug a 1 in right there. So we have 5 over 4 times 2 to the 1 power. Anything to the 1 power stays itself. So 5 over 4 times 2, and I'm just going to put it over 1, so it's easy to multiply, and you can just multiply straight across. And you can definitely use a calculator for this if you need to. What's 5 times 2? 5 times 2 is 10. 4 times 1 is 4. So there's our fraction. So when I plug in a 1, I get a 10 over 4. I'm going to plot that point. And the last one, 2. Plug that in. We have 5 over 4 times 2 squared. 2 squared is 4. So 5 over 4 times 4. And that's the same thing as 5 over 4 times 4 over 1. We'll just put it over 1 to make it easier on ourselves. What's 5 times 4? That's 20. And what's 4 times 1? That would be 4. 20 divided by 4 is 5. So I know that when I plug in a 2, I get 5. Okay, all of my points are plotted, so I'm going to draw the line. Number 19, same thing. Let's go ahead and plug these in. 1 over 4 times 5 to the negative 2. So that flips the fraction. So 1 over 4 times 1 over 5, and all of that is squared. Okay, that one right there is squared. And that becomes 1 over 4 times 1 squared is 1 over 5 squared. Remember, this just goes to both numbers. 5 squared is 25. And so that becomes 1 over 100. Okay, so when I plugged in a negative 2, I got 1 over 100. Plot that point, move on. 1/4, we've done this one now we're on this one, times 5 to the negative 1 power. That becomes 1/4 times 1 over 5. Remember, the negative 1, or the negative, makes us flip the fraction upside down, so that goes down there and the 1 goes up there. And then that's still to the 1 power, but 1 to the 1 power is 1, 5 to the 1 power is 5. So what's 1 times 1 is 1. What's 4 times 5 is 20. So when I put in negative 1, I get 1 over 20. Okay. 0, anything to the 0 power is 1. So if I put a 0 there, that makes this whole thing 1. 1/4 times 1 is 1/4. So when I plug in 0, I get 1/4. Okay. Now, let's plug in a 1. 1/4 times 5 to the 1 power. Anything to the 1 power is itself, so that's the same thing as 1/4 times 5, and I'm going to put that over 1 so we can just multiply straight across. That becomes 5/4. Okay, so when I plug in a 1, I get 5/4. Okay, when I do a 2, 1/4 times 5 squared. 5 squared is 25, so 1/4 times 25/1. That'll give me 25/4. So when I plot that, when I plot a 2, I get 25/4. There's my points. Draw the line. Good. Number 20. All we got to do is answer just a few questions about slope. Okay, and other things, but which graph has the steepest slope? So steep can either be like this, down, or it can be up. It doesn't matter. The steepest slope is the biggest number. So if that's like -5, take the absolute value. So that one, we're just looking at the 5. And let's say that one is 4. Okay, well 5 is higher than 4, so this would be the steepest slope. Okay, so same thing here. Let's go ahead and look at the different numbers. We go down 2/1, so this function is -2/1, which is the same thing as -2. Okay, this one's going up 1 for every 1, so that one is 1. Change in y over change in x. Or if you remember, y minus y, x minus x. That's our slope for tables. Okay, the slope here is a 3, and the slope here is a -4. So which one of those is the biggest number? That's a 1, that's a 2, that's a 3. So function 4 is the steepest. Okay. Now, which graph has the y-intercept farthest from 0? That's a y-intercept of 1. That's a y-intercept of -5. That's pretty far. There's 4 and there's 3. So -5 is the farthest from 0. So that would be function 2. Okay. Which functions have graphs with y-intercepts greater than -4? So what numbers are greater than -4? We have -4. Which ones are greater than? Well, that's -3, -2, -1, 0, 1, 2. Anything greater than -4 on a number line, right? So there's one greater than -4. That's not greater than -4. There's one that's greater than -4. So we have function 1 and function 3. And the y-intercept is -3, which is also greater than -4. So function 1, 3, and 4. Same question. Let's find our slope. We go up 1, 2, 3, 4, 5/1. So that's 5. Change in y, it's going down by 1 for every 1, so -1. This one is a -4, and this one is a 3. Okay, which function has a graph with the greatest y-intercept? That one's -4, that one's 3, so far that's the winner, -1, and 5. So we have our answer there. Graph or function 4 has the greatest y-intercept, the highest. Which function's graph is least steep? Now, if you think about it, least steep would be a perfectly flat line, right? Well, what would that slope be? That slope is 0. So the slope that's closest to 0 is the least steep. Okay? So what is this? That's a slope of 5, -1, 3, and -4. So that would be our least steep right there. Function 2, excuse me. Okay. Which functions have graphs with slopes less than -3? So that'd be -3, or -4, -5, -6. And there's one right there, -4. So that's the only one, function 3. And these last 3 questions. David sits on a bench instead of going to his house. So our y-intercept is his distance to his house. So he's not getting any closer to his house. He's not getting any farther from his house. He's staying the same distance from his house. Now, a plane speeds up before takeoff. So we look at the y-intercept. Always stop and look at the intercepts. That's time and the speed. X is almost always time. So the speed, it's starting slow and it's getting faster. So the speed is low and it's going up. So kind of like this one right here. The speed is slow and it's speeding up as time goes on. Okay, and this next one is a little more complex. A sightseeing ship is stopped in the water for an hour, miles from shore. Then the captain heads the ship back to the shore at a constant rate. The ship docks at shore for a while and then returns to open sea. So what happens? This is our distance to shore, and this is our time, obviously. So we're starting stopped, which means we're not getting any closer to shore, nor are we getting any farther from shore. So we're starting at a constant distance. Then he turns the boat on and heads back to shore. So his distance to shore is getting smaller and smaller and smaller until he's at shore. And he docks at shore for a while, so he's not getting any farther or any closer. And then he starts going back out to sea. So his distance from shore starts going up again. So that would be our best graph. Okay, Brian is working out by riding his bike. He starts by biking slowly at a constant rate, then he gradually picks up speed until he reaches his peak. He maintains this peak speed for the rest of his workout. So we look at a y. Y is his speed, and x, of course, is his time. So he starts by biking slowly at a constant rate. So it could either be that or that, but it's constant, so speed isn't changing, so it's not that one and it's not that one. He gradually picks up speed, so he starts getting faster. So both of those so far work until he reaches his peak, and then he maintains this speed for the rest of his workout. So he stops getting faster and gets constant again, so that would mean that the answer would be that graph. Okay, Maya's biking towards her campsite at a constant rate. Distance to campsite, that's what our y is. So she's getting closer to the campsite, which means her distance is going down. So it can't be that one, can't be that one, can't be that one. Well, that just leaves us right there. There's only one left. As she's getting closer, she sees the snake, turns and runs the other way, so she runs a little bit, and then she rests for a while. She's not getting any closer or farther from the campsite. Okay, now the next one, Pablo begins his jogging workout by running faster and faster and faster for about 1 minute. So his speed is increasing. Can't be that one, can't be that one, it can't be that one. His speed is increasing. Then he hits a comfortable pace, and then he gradually slows down. And the last question. David is driving on a freeway at a constant speed. He then speeds up to pass a truck. So his speed isn't changing. His y is his speed. It's not changing. It's constant. That one we see his speed increasing. Can't increase. Here we see his speed increasing. Can't increase. Here we see his speed decreasing. Can't decrease. That only leaves this one. His speed is constant. Then he speeds up to pass a car. Then he slows back down again. So that would be that answer. John is delivering a pizza to Mark's house. What is our y? Our y is his distance to his house. He drives at a constant speed. So think about it. He's driving closer to that house, which means his distance is getting slower or lower. Okay, this one, he's not getting any closer to the house, so it can't be that one. Again, here, he's not getting any closer to the house, so it can't be that one. And again, it's not getting any closer to the house, so he can't be that one. So we see here his distance is getting smaller, smaller, smaller as he gets closer. Then he hits a traffic jam and just sits there for several minutes. So his distance is not getting any closer to the house. And then he drives faster to get there faster, so his distance is getting there much faster. So it would be that one. Hopefully this helps you with the quiz. Let me know if you have any questions.